Taylor series. What is Taylor series? Taylor series is a power series, and it can be represented by fx is equal to summed over n from 0 to infinite, the nth derivative of the function at a point x equal to a divided by factorial n into x minus a whole to the power n. So this is your Taylor series. Okay, and this is nothing but a power series. And if you expand the Taylor series, then this will be in this form. This will be the first term when n is equal to 0. In the first term, it is the function itself, and this is the second term where you have first derivative of the function at the point a. This is the second derivative. You have this is the third derivative, and this is your nth derivative. So if you expand this power series, then this will be also the Taylor series. So why you use Taylor series? We use Taylor series to find out the nature of a graph or the nature of a curve at a point. Suppose you have a point A. You have a point A, and if you change the nature of the graph by taking the derivative, by taking the higher derivatives, then the nature of the graph will be changed. That means in the vicinity of the point A, if you take the derivative of the given function, then the nature of the graph will be changed. Then how the nature of the graph will be changed, that can be plotted by using Taylor series. Okay, and I have told you Taylor series is nothing but a power series, and the nature of the power series is fx is equal to summed over n from 0 to infinity a n x minus a whole to the power n. Here a n is the coefficient of nth term. Here x is the variable and n is also the variable, but a is a constant. Okay. Generally, when you find out the nature of any graph or nature of any curve at a point or nearer a point, we use this equation. Okay, here the point A is nothing but a value of the function. At x equal to a, you find out the nature of the graph. And x minus a, it is a very small quantity which we generally take in calculus as epsilon or delta. It is a very small quantity. So this means in the vicinity of the function, what will be the nature of the at the vicinity of the function? And in this power series, that is you have coefficient of the nth term a n, and if you find out the derivative, nth derivative of this function, that is the power series, then you can get a n is equal to the nth derivative of the function, then divided by factorial n. You see, I have found out the nth derivative of the function fx at a point a. So this will be the nth derivative of the function, and if you find out the value of the coefficient of the nth term, that will be equal to the nth derivative of the function at the point a divided by factorial n. So if you substitute the value of a n in the power series, you will get the Taylor series in this form. And remember, in Taylor series, fx is a real function or a complex valued function. Fx may be a real valued function or may be a complex valued function. Suppose we want to find out the nature of the function at a equal to 0. That means at the origin. If you plot the graph at x equal to 0 or at the origin, then what will be the function? What will be the Taylor series? Taylor series now will be equal to fx, that is equal to summed over n from 0 to infinite, the derivative of the nth derivative of the function at x equal to 0 divided by factorial n, and you have a minus x minus a in Taylor series. since a equal to 0, so you have x to the power n. This is a Taylor series which is generally at the origin of the coordinate system, and this power series is called Maclaurin series. This is called Maclaurin series when you plot the graph at the origin. Taylor series is called Maclaurin series as discovered by Maclaurin. So difference between the Maclaurin series and Taylor series is that you plot the function, when you plot the function at any point x equal to a, this is your Taylor series, and you plot the function at x equal to 0 at the origin, it will be the Maclaurin series. And remember, the first term of the Taylor series, that is equal to the function itself. Okay, the first term of the Taylor series is the function itself. That means the function, you cannot plot the exact nature of the function if you take the first term. But if you take the second term, that means the first derivative, then the nature of the curve will change. There is slight change in the nature of the curve. So you will get the exact nature of the curve when you take the successive derivatives. Okay, and here the factorial means the number of rearrangement. Okay, the factorial term gives the number of rearrangement because you are manipulating the nature of the curve. You are manipulating the nature of the curve. How the nature of the curve will be if you take the successive derivative of the function or slope of the function at the vicinity of the point A. Okay, you are manipulating the function to get the nature of the curve at the vicinity. That is why Taylor series is very useful while plotting the nature of the given function in a vicinity of any point. Thank you. And you will have question in the examination in core 1 Utkal University. You have a question in 2022, write Taylor series for a real function of real variables. So you may have short question like this: Taylor series for complex function for complex variables like this, or you have also many other problems. You practice it at home and write to me in the comment section. Thank you.